close your eyes and let the world around you begin to fade into a soft, distant hum. Imagine you are standing on a quiet, secluded beach at the very edge of an endless ocean. The air is cool and perfectly still, carrying the faint, clean scent of salt and ancient water. Beneath your feet, the sand is soft and fine, shifting gently as you settle into the stillness of the night. Above you, the sky is a vast, velvet tapestry, darker than any night you have ever known, and it is filled with a glittering, silent dust of light. You reach down and scoop up a single handful of that sand, letting the grains slip slowly, one by one, through your fingers. There is an old saying, often repeated by those who look at the heavens with wonder, that there are more stars in the observable universe than there are grains of sand on every beach on Earth. This is not merely a piece of poetry intended to stir the soul. It is a matter of cold, mathematical reality. Within the reach of our most powerful eyes, there are roughly 200 billion trillion stars. Each one of those points of light is a sun, a massive burning engine of heat and gravity. And we now know that these suns are not lonely. Many of them are orbited by planets of their own. For most of human history, these worlds were nothing more than a dream, a whisper of possibility in the dark. But in the recent breaths of our history, our technology has begun to pull back the curtain. The Kepler Space Telescope, a silent sentinel launched into the void, was designed to peer into just one small, unassuming patch of our sky. In that tiny sliver of the dark, it discovered over 2,600 confirmed exoplanets. If we take that small sample and extrapolate it across the entire, spiraling reach of our home galaxy, the numbers become staggering. We now estimate that there are between 100 and 400 billion planets in the Milky Way alone. Among those billions of worlds, there are planets that sit in habitable zones, the Goldilocks regions where the temperature is just right for liquid water to exist on the surface. Some of these worlds have been sitting in that peaceful warmth for billions of years, far longer than Earth has even hosted life. The sheer scale of these numbers seems to offer a guarantee. It suggests that in the vast, spinning clockwork of the cosmos, we cannot possibly be alone. Somewhere out there, surely, other intelligent beings have evolved, built civilizations, and looked up at their own night sky, wondering if anyone else exists in the great, yawning dark. And yet, as we listen to the stars, we are met with a chilling reality. We have found nothing. No signals have reached our ears. No visitors have landed on our shores. We have found no evidence whatsoever that any intelligence exists anywhere in the universe except here, on this one small blue planet. This is what astronomers call the Great Silence. It is the question that has haunted the minds of physicists and dreamers for decades. If the universe is so vast, so incredibly old, and so filled with opportunity for life to arise, where is everybody? The answer, when you work through the physics of the cosmos, is both simple and devastating. The universe is too big. It is not big in the way an ocean is big, or the way a continent is big. It is big in a way that defeats every strategy we could ever imagine for crossing it. The distances between stars are so vast that they might as well be infinite for any practical purpose. In a universe where nothing can exceed the speed of light, distance is not just a measure of space, it is a measure of time. To travel across the stars is to travel across human lifespans. It is to travel across the lifespans of entire civilizations. Our nearest neighbor, the star Proxima Centauri, is a mere 4.24 light-years away. A light-year is the distance light travels in 1 year, about 9.46 trillion kilometers. This means our closest neighbor is roughly 40 trillion kilometers from where you are resting right now. Think of the fastest spacecraft humanity has ever built, the Parker Solar Probe. At its peak velocity, it travels at about 700,000 kilometers per hour. Even at that incredible speed, reaching Proxima Centauri would take approximately 6,500 years. That is longer than the entirety of recorded human history. If we had launched a ship at the moment the pyramids of Egypt were being built, it would still have thousands of years left in its journey before it reached the nearest star. And Proxima Centauri is our immediate neighbor, practically touching us in cosmic terms. The Milky Way galaxy itself is roughly 100,000 light-years across. The center of our galaxy is 26,000 light-years away. There are stars on the far side of the galaxy so distant that the light leaving them right now started its journey when the first dinosaurs walked on the Earth. Any signal we might send, any spacecraft we might launch, would take tens of thousands of years to cross even a fraction of our home. As you continue to drift into this state of quiet contemplation, feel the peace that comes from understanding the true scale of the world. We sit in the silence, on our grain of sand, looking out at an ocean that is too wide to cross. But there is a strange comfort in this isolation. It means that our world is a sanctuary, a quiet island in a vast and ancient sea. And while the universe is large, your mind is capable of holding all of it: the stars, the distance, and the beautiful, haunting silence that remains. The transition from the sheer number of stars to the specific worlds that orbit them is a journey into the heart of potential. As you linger in this quiet, cosmic perspective, let your mind travel to those hundreds of billions of planets we now know exist within our own Milky Way alone. We used to think of our solar system as a rare jewel, a unique clockwork of planets circling a solitary sun. But the mathematics of the modern age tells us a different story. We now estimate that for every grain of sand you might hold in your hand, there are thousands of worlds spinning in the silence of the galaxy, each with its own landscape, its own gravity, and its own potential for a history. The Kepler Space Telescope changed everything we thought we knew about the neighborhood of our sun. By staring intently at one small, dark patch of the sky, a patch no larger than the palm of your hand held at arm's length, it revealed over 2,600 confirmed exoplanets. This discovery was like finding a bustling city in what we thought was a deserted wasteland. When astronomers take that small, crowded sample and apply it to the entire galaxy, the numbers become so vast they feel like a form of music. There are roughly 200 billion trillion stars in the observable universe, and many of them are orbited by planets. Among these billions upon billions of worlds, there is a specific category that draws our gaze more than any other. These are the planets that sit within the habitable zone, that delicate, shimmering region of space often called the Goldilocks zone. In these regions, a planet is positioned at just the right distance from its star, not so close that its oceans would boil away into steam, and not so far that its water would be locked in an eternal frozen grip. Here, in this temperate balance, liquid water could exist on the surface. And as far as we understand the story of life, where there is water, there is the possibility of a beginning. But the promise of these worlds is not just about their position in space, it is about their endurance through time. Our own Earth formed about 4.5 billion years ago, a relatively late arrival in a universe that has existed for nearly 14 billion years. Life on our planet appeared quite early in its history, perhaps within the first few 100 million years. Yet, there are planets in our galaxy that have been sitting in their habitable zones for far longer than Earth has even existed. Some of these worlds orbit stars that formed 8 or 9 billion years ago, long before our Sun was even a whisper of gas in a nebula. Think of what that means for the potential of life. If it took only a few 100 million years for life to arise on Earth, then these ancient worlds have had billions of years of opportunity. They have had an immense stretch of time, a duration that dwarfs the entire history of our species, to host the slow, patient crawl of evolution. On these worlds, life might have arisen, flourished, and reached levels of complexity and intelligence that we can barely conceive of, all while our own world was still a molten rock cooling in the dark. The numbers seem to provide a guarantee. If there are hundreds of billions of planets, and even a small fraction of them are habitable, then the galaxy should be a garden of life. Somewhere out there, surely, other intelligent beings have evolved and built civilizations of their own. They have likely looked up at their own night sky, seen the same distant stars that you see now, and wondered if they were truly alone in the vastness. They may have wondered if anyone else was out there, dreaming of contact and looking for a sign in the great, silent dark. This is the habitable promise, the idea that the universe is not a cold, dead void, but a place teeming with the potential for company. We see these worlds through our telescopes as tiny dips in light, mere shadows passing in front of distant suns, but in our minds they are vibrant and full of mystery. We imagine atmospheres of different colors, oceans that pull under the gravity of multiple moons, and skies that have never seen a human face. Yet, as we dwell on this promise, we must also confront the question that follows it. If the universe is so filled with opportunity, if it is so old and so rich in the materials for life, why have we found no signals? Why has no visitor ever crossed the threshold of our atmosphere? And why does the radio sky remain so perfectly, hauntingly quiet? This is the paradox that lies at the heart of our exploration. The numbers say we should be surrounded by neighbors, yet the reality we observe is one of profound isolation. As you remain in this stillness, let the weight of that silence be a comfort rather than a burden. It reminds us of the scale of the mystery we are part of. We are standing on a small blue island, looking out across an ocean that is not only wide in distance, but deep in time. The planets are there, the water is there, and the time has been there. The promise remains, even if the answer has not yet arrived. We are witnesses to a universe of infinite possibilities, a cosmos that has spent billions of years preparing the stage for a story that we are only just beginning to read. Everything we see, from the closest planet to the furthest galaxy, is part of a grand design that seems to favor the existence of worlds. And while we may be alone in this moment, we are surrounded by the evidence that we shouldn't be. The universe has provided the stars, the planets, and the billions of years of peace needed for life to emerge. The table is set, the lights are on, and the doors are open. And yet, the guests have not yet appeared. And so, we find ourselves standing at the edge of a great, shimmering contradiction. On one hand, we have the mathematics of the infinite, the hundreds of billions of stars and the trillions of planets that we have come to believe populate the vast, spiraling arms of our galaxy. On the other hand, we have the stark, cold reality of our physical experience. We look up at the night sky, and while it is filled with light, it is also filled with a profound and heavy silence. This mystery is what has come to be known as the Great Silence. It is the question that has haunted the dreams of astronomers and the calculations of physicists for decades, resting like a quiet weight upon the heart of human discovery. If the universe is so old, so vast, and so incredibly filled with the opportunity for life to arise and flourish, then why is it that we have heard nothing? Why is it that in all our years of searching, with our most sensitive instruments and our most hopeful hearts, we have found no signals, no visitors, and no evidence whatsoever that any intelligence exists anywhere else in the cosmos? This contradiction was perhaps best captured in 1950 during a simple lunch conversation involving the physicist Enrico Fermi. As the story goes, he and his colleagues were discussing reports of flying saucers and the possibility of interstellar travel. Amidst the casual talk, Fermi suddenly asked a question that would change the way we view our place in the universe. Where is everybody? It was a simple question, but it revealed a devastating gap between what we expect to see and what we actually observe. This is the Fermi paradox, the clash between the high probability of extraterrestrial civilizations and the complete absence of any proof of their existence. For over 60 years, humanity has tried to answer Fermi's question with action. Since 1960, the search for extraterrestrial intelligence, known as SETI, has been our primary way of reaching out into the dark. We have used increasingly sophisticated equipment to scan the heavens, monitoring millions of star systems across billions of different frequencies. We have listened for a single heartbeat in the radio spectrum, for a pattern of numbers that could not be made by a natural star, or for a greeting sent from a mind we do not yet know. And yet, after 6 decades of dedicated searching, the result has been absolute silence. Not a single confirmed signal of artificial origin has ever been detected. There has not been one unambiguous sign that anyone else is out there broadcasting their presence into the void. While this lack of evidence is not the same as proof that aliens do not exist, it forces us to confront a difficult reality. It suggests that either intelligent civilizations are extraordinarily rare, or they are choosing to remain quiet, or perhaps we are simply not listening in the right way. Consider, for a moment, our own presence in the radio sky. We often imagine that we have been announcing our existence to the galaxy for a long time, but on a cosmic scale, our voice is barely a whisper. We have been broadcasting radio signals for about 100 years, since the early days of our radio technology. These signals travel at the speed of light, moving outward from the Earth in a great, expanding sphere. After a century of broadcasting, this radio bubble has a radius of only 100 light-years. To us, 100 light-years seems like an immense distance, encompassing perhaps 15,000 stars. But in the context of the entire Milky Way, this bubble is almost microscopic. Our home galaxy contains hundreds of billions of stars, and our signals have reached roughly 0.00001% of that vast population. Outside of that tiny, fragile sphere of radio waves, the Earth is completely silent. To any civilization residing even a fraction of the way across the galaxy, there is no evidence that we exist at all. Furthermore, our signals are not as strong as we might hope. As they travel further from Earth, they become weak and diffuse, eventually becoming indistinguishable from the background noise of the universe. The idea that an alien civilization might have picked up our early television broadcasts and is now on its way to visit us is a beautiful story for science fiction, but it is not supported by the physics of our universe. For any intelligence to detect us, they would need to be within that small 100 light-year bubble. They would need to be listening at exactly the right frequency, at exactly the right time, and they would need technology far more sensitive than anything we currently possess. This leads us to a deeper part of the mystery. If we are so hard to find, then perhaps other civilizations are just as difficult to detect. If a civilization 50 light-years away detected our very first radio transmissions and sent an immediate reply, that message would only be reaching us now, a century after we began. We would be receiving their response today, perhaps having forgotten that we ever sent a signal worth answering in the first place. The silence demands an explanation, and there are many paths our thoughts could take. Perhaps civilizations are common across the vast stretches of time, but they flicker in and out of existence so quickly that they never happen to overlap. The galaxy might be filled with the ruins of civilizations that rose, flourished, and faded away, while our own ancestors were still microscopic organisms floating in the primordial seas. Or perhaps, as some have suggested, the L in the famous Drake equation, the length of time a civilization remains detectable, is typically very short. We have had advanced technology for only a century, yet we have already developed the capacity for self-destruction through nuclear weapons and climate change. It is a sobering possibility that the same intelligence required to build a radio transmitter also leads a species to build weapons capable of its own extinction. If the average lifespan of a technological society is only a few thousand years, then the chances of two such societies existing close enough to hear one another are vanishingly small. As you settle into this quiet reflection, let the silence of the cosmos be a space for your imagination to wander. We are part of a grand search, a species that has spent its brief time in the sun looking for a reflection in the mirror of the stars. We are a part of the universe that has developed ears to hear and eyes to see. Yet we find ourselves in a room that appears to be empty. But there is a certain peace to be found in the silence. It reminds us of the profound value of our own world and the unique story we are writing here. Even if the silence remains absolute for the rest of our history, the act of listening is itself a noble endeavor. It is a testament to our curiosity and our desire to belong to something larger than ourselves. The great silence is not necessarily a sign of a dead universe. It may simply be a sign of a universe that is waiting, a cosmos so vast that it takes more than a century for the first echoes of life to find their way home. We continue to watch, and we continue to listen, holding our breath as we scan the dark. We are the watchers on the shore, looking out across an ocean of stars, waiting for a single light to blink back at us from the horizon. And until that light appears, we have each other, and we have the quiet beauty of a universe that is big enough to hold all our questions. As we leave behind the quiet hum of our radio telescopes and the haunting absence of signals from the stars, we must turn our gaze toward the physical architecture of the cosmos itself. The silence we have discussed is not merely a matter of bad luck or poor timing. It is a direct consequence of the very way the universe is built. To understand why we are alone, we must confront the geometry of space, a scale of existence so vast that it defeats every strategy we might imagine for crossing it or communicating across it. In our daily lives, we use the word big to describe the things that tower over us. We speak of the oceans as big or the continents as big. But when we move beyond the thin veil of our atmosphere, the word loses its meaning. The universe is big in a way that makes our planetary scale appear as nothing more than a mathematical point. The answer to why the heavens are quiet, when you work through the cold hard physics of it, is both simple and devastating. The universe is just too big. The distances between stars are so immense that they might as well be infinite for any practical purpose. This scale is not just a challenge for our engines, it is a challenge for our reality. In a universe governed by the laws of physics, distance translates directly into time. Because nothing carrying information can exceed the speed of light, every kilometer of space becomes a second of waiting. On a cosmic scale, these seconds stretch into years, then into centuries, and eventually into spans of time that exceed the lifespans of human beings and the civilizations they build. To look across the room is to see the present. To look across the galaxy is to see a past that may no longer exist. To truly grasp this, we must look at our own immediate neighborhood. Our closest neighbor in the dark, the star Proxima Centauri, sits a mere 4.24 light-years away. In the grand map of the galaxy, it is practically touching us. Yet this neighborly distance is 40 trillion kilometers. If we were to take the fastest machine humanity has ever constructed, the Parker Solar Probe, which peak velocities at 700,000 kilometers per hour, and point it toward that nearest star, the journey would take approximately 6,500 years. Think of the weight of that number, 6,500 years. If a group of travelers had set out for Proxima Centauri at the very dawn of recorded human history, when the first cities were being built and the first words were being written, they would still be in the cold, dark void today. The pyramids of Egypt would have risen, flourished, and turned into ancient ruins before that spacecraft ever arrived at its destination. And this, remember, is for the star that is right next door. Beyond our immediate neighborhood, the scale expands into the impossible. Our home, the Milky Way, is roughly 100,000 light-years across. If you were to send a signal at the speed of light, the fastest anything can move in this universe, to the center of our galaxy, it would take 26,000 years to arrive. By the time your message reached the stars at the far side of our galaxy, the light leaving them right now would be reaching a version of Earth where the first dinosaurs were just beginning to walk. This isn't just a technological hurdle that we can jump over with better engineering. This is the fundamental property of space-time itself. We often think of the speed of light as a limit that we might one day break, but in physics, it is a wall. No signal, no spacecraft, and no message in any form can cross interstellar distances faster than light allows. And on the scale of the cosmos, light is agonizingly slow. Imagine for a moment two civilizations living on opposite sides of the Milky Way. They are both intelligent, both curious, and both looking for a friend in the dark. If one sends a greeting at the speed of light, it takes 100,000 years to reach the other side. If the other civilization replies immediately, that response takes another 100,000 years to return. A single exchange of hello would span 200,000 years, a period longer than modern humans have even existed as a species. Any meaningful conversation would require millions of years. By the time a reply arrived, the civilization that sent the original message might have gone extinct, evolved into something unrecognizable, or forgotten that a message was ever sent at all. When we broaden our view even further, the Milky Way itself becomes a tiny island. It is just one galaxy among hundreds of billions. Our nearest large neighbor, Andromeda, is 2.5 million light-years away. The observable universe extends 46 billion light-years in every direction, containing structures so vast that our entire galaxy is like a single grain of sand on an endless beach. In a universe of this scale, the geometry says no to our dreams of meeting. The distances are the ultimate barrier. Every factor we can measure or calculate suggests that intelligent species, if they exist, are islands in an ocean of space and time so vast that no bridge could ever connect them. We might share the universe with countless other minds, yet remain forever alone, separated not by malice or indifference, but by the simple, cold geometry of a cosmos too large to cross. As we sit in this silence, it is helpful to realize that this isolation is not a failure. It is simply the nature of the container we inhabit. The universe does not want to keep us apart. It is simply so large that being together is a concept that doesn't apply to the stars. We are witnesses to a geometry of the infinite, and while we may never shake the hand of an alien being, we can take solace in the fact that we are part of a structure so grand that it defies our very ability to traverse it. The silence is the sound of scale. It is the sound of 40 trillion kilometers of empty space between us and the nearest sun. It is the sound of 200,000 years of waiting for a single word. And in that silence, there is a kind of peace. The peace of knowing that our little world, this island in the dark, is a precious, rare, and protected sanctuary, held apart from the rest of the cosmos by the very laws of physics that govern the stars. As we delve deeper into the nature of our isolation, we must confront the most immovable object in all of physics. It is the invisible wall that keeps every civilization contained within its own small bubble of time. This is the speed of light, the ultimate cosmic speed limit. To our human senses, light seems instantaneous. When you flip a switch in a dark room, the light fills the space so quickly that there is no measurable delay. But as we look out into the great yawning void of the universe, we discover that light, the fastest thing in existence, is actually agonizingly slow. The speed of light is roughly 300,000 kilometers per second. It is a number so large it feels abstract, but in the context of the cosmos, it is a staggering limitation. It is not just a speed limit that applies until we find a way to build a faster engine. It is a fundamental property of space-time itself. Nothing that carries information, no signal, no spacecraft, no message in any form, can ever exceed this speed. It is the universal constant that binds everything together, yet simultaneously keeps everything apart. Imagine you are standing on the Earth, looking up at the Moon. The light you see reflecting off its silver surface took about 1¼ seconds to reach your eyes. You are not seeing the Moon as it is right now, but as it was a moment ago. When you look at the Sun, you are seeing light that began its journey 8 minutes ago. If the Sun were to suddenly vanish, we would continue to bathe in its warmth and light for 8 full minutes, blissfully unaware of its absence. Image showing the light travel time between the Sun and various planets in the solar system. As we look further out, this time delay becomes a vast, unbridgeable chasm. The stars you see in the night sky are not glimpses into the present, but windows into the past. You are looking at light that may have been traveling for decades, centuries, or even millennia before it finally reached the lens of your eye. To look at the stars is to look through a telescope into history itself. This brings us to a devastating realization regarding interstellar communication. Because light is the messenger, any conversation across the stars is doomed by the physics of delay. If we were to detect a signal from a civilization orbiting a star 100 light-years away, we would be receiving a message that was sent a century ago. If we were to send a reply immediately, it would take another 100 years to reach them. By the time our hello arrived, 200 years would have passed on both worlds. The original senders would be long dead, and the world they lived in might have changed beyond recognition. This is the barrier of causality. In our universe, cause and effect are linked by the speed of light. Because no information can travel faster than light, no two civilizations can ever truly interact in real time. Every intelligent species is essentially trapped in its own light cone, a region of space and time that it can influence or communicate with. Beyond that cone, the rest of the universe is a silent spectator, forever out of reach. This cosmic speed limit is why the idea of a galactic empire, so common in our films and books, is likely a physical impossibility. An empire requires coordination, trade, and rapid communication to survive. But how can a civilization govern a territory that takes 10,000 years to cross? By the time a command reaches a distant colony, the government that issued it may have fallen centuries prior. The sheer scale of space, enforced by the slowness of light, ensures that every star system must remain an independent island. We often dream of warp drives or wormholes, shortcuts through the fabric of space that would allow us to bypass this limit. And while these concepts exist in the complex mathematics of general relativity, they remain largely theoretical curiosities that may never be realized in our physical reality. To create a warp bubble, one might need energy quantities equivalent to the mass of entire stars or exotic matter with properties that may not even exist in nature. For all practical purposes, we are bound by the law of light. As you reflect on this, let the steady, unchanging nature of the speed of light provide a sense of order. It is the heartbeat of the universe, the pulse that determines the rhythm of existence. While it keeps us from meeting our neighbors, it also protects us. It ensures that the universe remains a place of mystery and vastness, a place where every world can develop its own unique story without interference. The speed of light is the reason the night sky is so beautiful. It is a gallery of different eras, all visible at once. We see the light of a star that died 1,000 years ago, alongside the light of a planet that is just beginning to form. We are witnesses to a grand, slow-motion ballet that spans billions of years. And though we may never cross the void to touch those distant fires, we are connected to them by the very light that keeps us apart. Everything in the cosmos is governed by this quiet, invisible rhythm. We are part of a universe that values its distances, a universe that demands patience on a scale we can barely imagine. The light is the messenger, but it is a messenger that takes its time, carrying the stories of 1,000 worlds across the dark, silent sea of space. As we float through the silent, velvet dark of the cosmos, we find ourselves turning our attention toward the porchlight of our own solar system. It is time to look closer at our immediate surroundings, at the few flickering candles that share our small corner of the Milky Way. When we speak of the stars, our minds often jump to the entire galaxy or the vast clusters of light in the distant void. But the true scale of our isolation is best understood by looking at our local neighbors. These are the stars that are practically touching us in cosmic terms, yet they remain further than any distance a human being has ever traveled. The nearest star to our own sun is a small, dim red dwarf known as Proxima Centauri. It sits at the heart of our immediate neighborhood, only 4.24 light-years away. In the grand sprawling map of a galaxy that spans 100,000 light-years, Proxima is our next-door neighbor. It is so close that its gravity is bound to two other stars, Alpha Centauri A and B, forming a triple star system that dances together in the dark. To an astronomer, this distance is a mere hop across a stream. But to us, resting here on our small blue world, that hop represents a journey of 40 trillion kilometers. 40 trillion. It is a number that the human mind can name but cannot truly feel. To cross such a distance, we would need to leave behind everything we have ever known. If we were to take the fastest machine humanity has ever constructed, the Parker Solar Probe, which peak velocities at 700,000 kilometers per hour, and point it toward that nearest neighbor, the journey would take approximately 6,500 years. Let the weight of that time settle over you like a heavy, warm blanket. 6,500 years. This is a duration of time that exceeds the entirety of recorded human history. If a group of travelers had set out for Proxima Centauri at the very moment the first cities were being built in Mesopotamia, or when the first words were being carved into stone, they would still be in the cold, dark void today. They would still be thousands of years away from their destination. The pyramids of Egypt would have risen from the desert sands, flourished under the sun, and turned into ancient, weathered ruins before that spacecraft ever arrived at its destination. When we look at Proxima Centauri through our telescopes, we see more than just a point of light. We see a sun that is much smaller and cooler than our own, a deep red ember burning in the night. And around this ember, we have discovered planets. One of them, Proxima b, sits in the habitable zone of its star. It is a world roughly the size of Earth, potentially cool enough for liquid water to pool on its surface. It is the closest other Earth we will ever know. It is our immediate companion in the darkness, a world that might, in some distant era, host the footsteps of life. But even though this world is right there, it remains effectively out of reach. Every signal we send to Proxima takes over 4 years to arrive. If we were to say hello today, the answer, even if sent back instantly at the speed of light, would not reach us for nearly 9 years. This is the closest conversation we could ever hope to have. And if we wanted to go there ourselves, to walk on those alien shores and see a red sun hanging in a foreign sky, we would have to commit ourselves to a journey that spans hundreds of generations. This is the reality of the generation ship, a concept where a vessel becomes a traveling world. The people who launched the ship would never see the destination. Their children and their children's children would be born, live, and die within the metal walls of a craft, knowing the stars only through the sensors of their ship. It would be the descendants of the original crew, thousands of years later, who would finally see the light of Proxima Centauri grow from a distant spark into a burning sun. But what kind of society could survive such a journey? What language would they speak after 6,000 years of isolation? What stories would they tell about the Earth, a home they had never seen, and that had likely faded into the realm of myth and legend? The distance is not just a measure of space. It is a filter that strips away everything but the most essential parts of our being. Beyond Proxima, our other neighbors are even further away. Barnard's star lies 6 light-years out. Sirius, the brightest star in our sky, is nearly 9 light-years distant. Each of these is a sun with its own story, its own potential for planets, and its own vast, empty moat of space. We are like people living on widely scattered islands in an ocean so large that we can see the smoke from each other's fires on the horizon, but we can never build a boat strong enough to cross the waves. As you reflect on these local stars, let the silence of the space between them wrap around you. It is a quiet that is not empty, but full of the potential for things we can barely imagine. Our local neighborhood is a small cluster of light in a much larger, darker forest. And while the distances are daunting, there is a beauty in the fact that we have neighbors at all. We are not a lone spark in a void. We are part of a local family of stars, even if we are destined to remain in our own separate rooms. The stars are there, constant and unchanging, watching over us as we dream. They are reminders that the universe is vast, but it is also structured. Every star has its place, and every planet has its path. We are exactly where we are meant to be, on a world that has everything we need, looking out at a neighborhood that is beautiful, precisely because it is so far away. The light from Proxima Centauri that is entering your eyes tonight began its journey years ago. It has traveled through the cold, silent vacuum to find you, a message from our closest friend in the dark. And though we may never cross that 40 trillion kilometer bridge, the light connects us. It tells us that we are part of a neighborhood of suns, a small corner of the galaxy where the fires are lit and the night is not quite so lonely as it seems. Everything is as it should be. The distances are there to protect the unique stories of every world, and the time is there to allow those stories to unfold at their own pace. Rest now, knowing that the neighborhood is quiet, the stars are in their places, and the journey, though long, is filled with a light that never truly fades. Now, let the local neighborhood of Proxima Centauri fade like a flickering candle in the distance as we pull our perspective further and further back, ascending through the layers of the cosmic ocean. We have spent time among our closest friends, the stars that share our immediate corner of the dark. But now it is time to witness the true majesty of the structure they belong to. As we rise, the individual points of light begin to blur and blend, merging into a grand, spiraling river of silver and gold. This is our home, the Milky Way, a celestial city of such immense proportions that it defies every measure of human experience. Imagine this great, spinning disk of light. From our vantage point deep within one of its arms, the Milky Way appears to us as a faint milky band stretching across our night sky. But from this new, higher perspective, we see it for what it truly is, a majestic, winding staircase of stars, roughly 100,000 light-years across. It is a gargantuan collection of 100 to 400 billion planets and an equal number of suns, all held together by the invisible threads of gravity, spinning slowly through the void. As we drift above the galactic plane, we can see the great spiral arms, the Sagittarius arm, the Perseus arm, and the Orion spur, where our own solar system resides. These arms are not solid structures. They are waves of density, places where gas and dust are compressed to give birth to new generations of stars. They glow with the soft pink light of nebulae and the brilliant blue-white fire of young suns. Between these arms lie vast, dark lanes of cosmic dust, the silent shadows of the galaxy where the materials for future worlds wait to be stirred into life. In this grand scale, the distances we spoke of before, the trillions of kilometers to our nearest neighbor, become infinitesimal. They are like the space between two single grains of dust in a desert that spans a continent. To cross the Milky Way at the speed of light would take 1,000 centuries. To cross it at the speeds of our fastest rockets would take millions of years, a span of time so long that the species that launched the craft would likely have evolved into something entirely different, or vanished from the universe altogether, long before the journey was even halfway complete. Let your gaze travel toward the heart of the galaxy, the galactic center. It is located roughly 26,000 light-years away from where you are resting now. At the core of this celestial city, the stars are packed so tightly together that the night sky on a planet that would be as bright as the day is on Earth. It is a place of incredible energy and ancient history, where a supermassive black hole sits in the silent center, a dark anchor around which billions of stars perform their slow, multi-million-year dance. The light we see from that central bulge right now began its journey toward us 26,000 years ago. When that light first left its home, humanity was in the midst of the last ice age. Our ancestors were living in caves, painting the walls with the images of mammoths and bison, unaware that a message of light was beginning a journey that would span the entire development of human civilization before reaching their descendants' eyes. This is the look-back time of the galaxy, the realization that to look at the center of our home is to look deep into a past we can never touch. And yet, even the center is only the midpoint. If we look toward the far side of the galactic disk, the scales become even more haunting. There are stars on the opposite edge of the Milky Way, whose light is only just now reaching the Earth. That light has been traveling through the vacuum for 100,000 years. When that light began its journey, modern humans were just beginning to emerge in Africa. We had not yet mastered the art of the bow, or the taming of fire for heat, or the sowing of seeds. That light has traveled through the silent dark, witnessing the entire rise of our species from a distance, carrying the image of a galaxy that existed long before the first word was ever spoken on our world. Think of the isolation this scale imposes. If an intelligent civilization exists on the far side of the galaxy, and they were to send a signal toward us today, it would not arrive for 100,000 years. If we were to hear it and send a reply immediately, another 100,000 years would pass before our answer reached them. In that 200,000-year interval, whole empires could rise and fall. Great cities could be built, crumble into dust, and be forgotten by history. Species could emerge, develop technology, and go extinct, all within the time it takes for a single exchange of greetings to cross the galactic threshold. This is why the Great Silence is so profound. It is not necessarily that the galaxy is empty, but that it is too large for its inhabitants to ever truly know one another. We are like people living on opposite sides of a vast, dark ocean, lighting small candles on our shores. The light from our candle is too faint to be seen from the other side, and by the time it could ever reach those distant eyes, our candle would have long since burned out. We often imagine our presence in the galaxy to be significant, but when we look at our radio bubble, we see the humble reality of our situation. We have been broadcasting radio signals for about a century. Those signals, traveling at the speed of light, have created a sphere of human presence that is 100 light-years in radius. In the context of a galaxy that is 100,000 light-years across, this bubble is a mere speck. We have touched only about 0.00001% of the Milky Way. To the vast majority of the stars in our own home galaxy, the Earth is still a silent, dark planet, showing no sign that anything more complex than bacteria has ever graced its surface. This creates the image of the galaxy as an archipelago of light, a collection of isolated islands of intelligence, separated by such immense gulfs of space and time that they might as well be in separate universes. Each civilization is born, lives its history, and perhaps fades away, all within its own small bubble of light, never knowing that a neighbor might be doing the same thing just a few hundred light-years away. As you drift in this majestic, spiraling silence, let the scale of the Milky Way bring you a sense of profound peace. We are part of something so large that our individual worries and the small troubles of our world seem to dissolve into the silver mist of the stars. We are residents of a galactic city of 400 billion suns, a place of infinite variety and ancient beauty. And while we may be separated from our neighbors by the vastness of the spiral arms, we share the same home, the same gravity, and the same ancient history of the cosmos. The galaxy is not a void, it is a tapestry. It is a story written in light and shadow, spanning billions of years and hundreds of billions of worlds. And though we may be a small part of that story, we are the part that has learned to look up and appreciate the whole. We are the eyes of the Milky Way, the consciousness that allows the galaxy to finally see itself. Rest now in the center of the spiral. The stars are in their orbits, the arms are turning in their slow, silent rotation, and the light from 100,000 years ago is finally finding its way to your eyes. The galaxy is wide, the night is quiet, and you're exactly where you belong in the grand, luminous reach of our home. As the majestic silver spirals of the Milky Way begin to pull further away, we find ourselves leaving the comfort of our home galaxy behind. The billions of stars that felt like an infinite city just moments ago now begin to shrink, huddling together into a single, glowing smudge of light against the deepest black you can imagine. We are entering the intergalactic void, the great hollow spaces that exist between the islands of the universe. Here, the silence is even deeper, and the distances are so vast that our entire galaxy, our 400 billion stars and all their history, becomes nothing more than a single grain of sand on an endless, invisible beach. In this vast emptiness, there is almost nothing. No stars, no planets, no dust. Only the faint, ancient glow of the Big Bang and the invisible pull of gravity. It is a place of absolute stillness. But as we drift through this hollow dark, a new light begins to grow on the horizon. It is a soft oval glow, larger and more imposing than the home we just left. This is Andromeda, our nearest large neighbor in the cosmos. Andromeda is a sister to our Milky Way, a great, swirling collection of stars that sits 2.5 million light-years away. Think of that number for a moment. When we look at Andromeda through a telescope, the light that enters our eyes has been traveling through the void for 2.5 million years. That light began its journey before the first humans had even walked the Earth. It has traveled through the vacuum of space, across the great nothingness, just to find you here tonight. Image comparing the sizes of the Milky Way and the Andromeda Galaxy. When we speak of meeting aliens or making contact, the scale of this intergalactic gap makes the idea almost impossible to conceive. If there were a civilization in Andromeda looking back at us right now, they would not see the lights of our cities or the signals of our radios. They would see the Earth as it was 2.5 million years ago, a wild prehistoric world where our ancestors were still millions of years away from discovering fire or language. To them, we do not yet exist. And if we were to send a signal to them today, it would not arrive until the year 2,502,026. By then, the very memory of our civilization might be dust. This is the reality of the universe's structure. It is a collection of islands, and the ocean between them is so wide that no bridge can ever be built. The observable universe extends 46 billion light-years in every direction, containing hundreds of billions of galaxies, each with its own billions of stars. It is a scale that makes our own lives feel like a single breath in an eternal storm. Yet, as we look out at this endless beach of galaxies, we find ourselves returning to that one profound realization. There are more stars in the universe than there are grains of sand on every beach on our planet. Imagine standing on a beach that stretches forever. Every grain of sand you see represents a sun, and many of those grains have even smaller specks of dust orbiting them, the planets. The sheer mathematics of it seem to guarantee that we are not alone. Surely, on one of those trillions of grains of sand, another mind has woken up. Surely, someone else is standing on their own shore, looking out at the same dark ocean, feeling the same combination of wonder and loneliness that we feel now. And yet, the silence persists. We scan the heavens, we point our dishes at the furthest galaxies, and we hear nothing but the static of the stars. The geometry of the cosmos seems designed to keep us apart, sealing every intelligence into its own small bubble of space and time. We are neighbors who can never meet, witnesses to a grand performance who can never speak to one another across the aisles. As you drift further into this contemplative state, let the vastness of the intergalactic void bring you a sense of quiet perspective. We are a part of a structure so large that our individual existence is almost impossible to represent, but being small does not mean being insignificant. In all this vast, dark ocean, we are the only ones we know of who are counting the grains of sand. We are the part of the universe that has learned to name the galaxies and measure the light of distant suns. The emptiness between the galaxies is not a wall, but a testament to the scale of the creation we belong to. It is a space for the universe to breathe, a buffer that protects the unique stories of every galaxy. As you rest, remember that while the distances are unbridgeable, the light still travels. The light from Andromeda is finding you. The light from our own sun is heading out into that same void, carrying the image of our world into the future. We are one grain of sand, but we are a grain that can see the whole beach. We are a small light in a vast dark, but we are burning brightly. The intergalactic void is quiet, the galaxies are in their places, and the universe continues its slow, ancient expansion. You are safe on your small island, surrounded by a cosmos that is too big to be lonely, and too beautiful to be anything other than a home. Now, as we retreat from the staggering, lonely depths of the intergalactic void, let us turn our minds back toward home. We have seen the billions of galaxies and the trillions of stars that populate the endless beach of the cosmos. But now we must look at the tiny, fragile footprint we have left upon that shore. We must look at our radio bubble, the thin, expanding shell of our own presence in the universe. It is a story of a single century, a brief heartbeat in the life of a galaxy, and it reveals more than anything else just how small our voice truly is in the face of the great ancient silence. For billions of years, the Earth was a silent world. It was a place of crashing oceans, of rustling forests, and of the calls of animals. But to the rest of the universe, it was as quiet as a stone. Then, just over 100 years ago, something changed. We learned to harness the electromagnetic spectrum. We learned to turn our words, our music, and our images into waves of invisible light and send them out into the air. What we did not fully realize at the time was that we weren't just talking to each other across the continents. We were beginning to shout into the stars. These signals, from the first crackling radio broadcasts to the high-powered television transmissions of the mid-20th century, do not stop at the edge of our atmosphere. They continue onward, traveling through the vacuum of space at the speed of light. They move past the moon in a second, past the sun in 8 minutes, and past the outer reaches of our solar system in a matter of hours. Since the early 1900s, these signals have been moving outward in every direction, forming a perfect, expanding sphere centered on our small blue planet. As you drift in this quiet contemplation, imagine this sphere. It is our radio bubble. After a century of broadcasting, this bubble now has a radius of roughly 100 light-years. In our human minds, 100 light-years feels like an immense territory. It encompasses approximately 15,000 star systems, each with its own sun and its own collection of planets. We might imagine that within this bubble, the galaxy is buzzing with the sounds of our history. We might imagine that any neighbor within that reach is currently listening to our old news reports, our orchestral symphonies, or the flickering shadows of our first black and white television shows. But then, we must look at the scale of the map. The Milky Way galaxy is 100,000 light-years across. It contains hundreds of billions of stars. When you place our 100 light-year bubble into the context of the entire galaxy, it practically disappears. Our radio presence has reached roughly 0.00001% of the stars in our own home, to the vast, overwhelming majority of the galaxy, to the billions of stars in the spiral arms and the dense golden cluster of the galactic center. The Earth is still as silent as it was in the days of the dinosaurs. We have barely scratched the surface of the cosmic ocean. And there is a further, more humbling reality to consider. As our signals travel further and further away from Earth, they do not stay strong. They obey the laws of physics, spreading out and thinning as they cover more distance. By the time our radio waves reach even the nearest stars, they have become incredibly weak, diffuse, and faint. At any significant distance, they are largely indistinguishable from the background noise of the universe, the static left over from the Big Bang, or the chaotic radio chatter of the stars themselves. The popular idea that aliens might be watching our old television reruns is, unfortunately, more science fiction than physics. For a civilization to actually receive a signal from Earth, a series of incredibly unlikely conditions must be met. They would need to be located within that tiny 100 light-year bubble. They would need to be listening at exactly the right frequency at exactly the right time. And they would need technology capable of detecting signals so faint that they are almost buried in the static of the cosmos. Even if all those conditions were met, we are still bound by the slow, rhythmic pace of light. If a civilization 50 light-years away, halfway to the edge of our bubble, detected our very first radio transmissions today, their reply would take another 50 years to reach us. We would receive their response a century after we first announced our presence. We would be receiving their hello now, perhaps having forgotten that we ever sent anything out into the dark worth responding to. This is the nature of interstellar conversation. It is not a dialogue, but a series of echoes across a canyon so wide that the speakers may pass away before the sound returns. As we look at our fading, tiny bubble, we must also consider the future of our own silence. We are already changing the way we communicate. In our early days, we used powerful, omnidirectional antennas that leaked vast amounts of energy into space. But today, we are moving toward more efficient technologies. We use fiber optics that keep our data trapped in cables beneath the Earth, and we use highly directed satellite beams that don't spill their energy into the void. We are, in many ways, becoming quieter to the rest of the galaxy, even as our own world becomes more connected. It is possible that this is a universal pattern. Perhaps every civilization has a radio window, a brief century or two where they are loud and detectable before they move on to more advanced, more silent forms of technology. If this is true, then searching for radio signals is like looking for a single, brief spark in a dark forest that lasts for only a second. If we aren't looking at exactly the right moment, we will miss it entirely. This realization brings a strange sense of peace to our isolation. It suggests that the great silence we hear when we look at the stars might not be the silence of a dead universe, but the silence of a mature one. It might be that the galaxy is full of life, but that life has moved beyond the noisy, primitive stage of broadcasting its presence to the stars. They may be communicating in ways we cannot yet imagine, using lasers or gravitational waves, or even the strange properties of quantum entanglement, leaving our radio telescopes to listen to an empty room. As you rest in the center of your own quiet world, let the image of our radio bubble be a comfort. It is our message in a bottle, a tiny light we have lit in the darkness. It may be small, and it may be fading, but it is a testament to our desire to be known. It is the footprint of our curiosity, expanding at the speed of light through the ancient, silent dust of the Milky Way. We are a young species, still in the very first moments of our technological awakening. Our bubble is small because our history is short, but every second that bubble grows. Every second, our voice reaches a few more miles into the dark, carrying the stories of our world to stars that have never heard them. We are part of a grand experiment, a species that is learning to speak to the universe, even if the universe hasn't yet learned how to answer. The night is vast and the silence is deep, but our little light is still burning. We are here, on our small island, sending our echoes into the sea. And while we wait for a reply that may not come for 1,000 years, we can take pride in the fact that we had the courage to shout into the dark at all. The bubble is growing, the stars are waiting, and the story of our world is continuing its long, slow journey through the heavens. Since we have witnessed the tiny, expanding shell of our own presence, our fading radio bubble, it is time to look at the other side of that same coin. For as long as we have been shouting into the dark, we have also been holding our breath, straining our ears to catch a single, artificial heartbeat in the static of the stars. This is the story of SETI, the search for extraterrestrial intelligence. It is a journey that began over 60 years ago, born from a combination of scientific curiosity and a deep human longing to know that we are not alone in the immense cold theater of the universe. The search officially began in the spring of 1960. A young astronomer named Frank Drake pointed a single radio telescope at the stars, Tau Ceti and Epsilon Eridani. He called it Project Ozma, named after the princess of the imaginary land of Oz, a place far away, difficult to reach, and filled with strange and wonderful things. For several weeks, he listened to the hiss and crackle of the cosmos, hoping for a pattern, a sequence of numbers, or anything that didn't sound like the natural noise of a star. He heard only silence. But that silence did not discourage him. It was the first step in a search that would span generations. Since that spring in 1960, our efforts have grown in scale and sophistication. We have built massive arrays of telescopes that work together as a single, giant ear. We have developed computers capable of scanning billions of frequencies every second, searching for a needle in a haystack the size of a galaxy. We have looked at millions of star systems, from our closest neighbors to the dense clusters in the heart of the Milky Way. And yet, after more than 6 decades of increasingly powerful observation, the result remains the same: absolute silence. Think of what that silence means as you drift deeper into the stillness of your own room. We have monitored the radio spectrum across nearly every conceivable band. We have looked for laser pulses, for infrared heat from massive engineering projects, and for the strange shadows of megastructures that might be orbiting distant suns. Not once have we found an unambiguous sign of artificial origin. There's been no hello, no mathematical greeting, and no cosmic broadcast. The universe, as far as we can detect, appears to be an empty house. This absence of evidence is a profound mystery. It forces us to ask why. Perhaps the search itself is based on a set of assumptions that don't apply to the rest of the galaxy. We search for radio waves because that is the technology we understand. But we have already seen how our own world is moving toward quieter, more directed ways of communicating. A civilization only a few centuries ahead of us might use methods that are completely invisible to our current instruments: gravitational waves, quantum entanglement, or things we haven't even named yet. We might be standing in a forest, listening for the sound of a drum, while everyone else is communicating using a digital network we haven't discovered how to join. Or perhaps the silence is a matter of frequency. The electromagnetic spectrum is vast. Searching for an alien signal is like trying to find a single, specific station on a radio dial that has billions of channels. If we are off by just a fraction, the signal remains hidden in the static. Astronomers often speak of the water hole, a quiet band of frequencies between the emissions of hydrogen and hydroxyl, the two components of water. They hoped that any water-based life form would naturally choose this hole in the cosmic noise to speak to others. We have scoured the water hole, and yet the static remains. Despite the silence, the search continues. It continues because the stakes are so high. To find even a single confirmed signal would be the most significant moment in the history of our species. It would mean that intelligence is a universal phenomenon, not a local accident. It would mean that it is possible for a civilization to survive the dangerous phase of its own technological youth. A single signal would be a message of hope, a bridge across the infinite dark. But as the years turn into decades, the silence takes on a weight of its own. It suggests that if civilizations are out there, they are either very rare or they are very quiet. Some scientists have suggested that the search has barely begun, that we have searched the equivalent of a single glass of water from the entire Earth's ocean. They argue that we must be patient, that we must build larger telescopes, and that we must listen for hundreds or even thousands of years before we can draw any conclusions. As you reflect on these 60 years of listening, let the resilience of the searchers inspire you. There is a quiet beauty in the act of listening to a universe that doesn't answer. It is a testament to our curiosity and our enduring hope. We are like children calling out into the night, waiting to hear a voice call back. And even if we never hear a reply, the act of calling out makes us who we are. It defines us as a species that refuses to believe that the darkness is empty. The search for SETI is more than a scientific project. It is a mirror. It shows us our own loneliness, but it also shows us our profound significance. In a galaxy of 400 billion stars, we are the ones who have built the ears to listen. We are the ones who have dedicated our lives to the possibility of a neighbor. And until the silence is broken, we continue to hold the watch. We continue to scan the frequencies, to analyze the patterns, and to wonder about the minds that might be hiding just beyond our reach. The universe is a vast and ancient place, and we've only been listening for a heartbeat of its history. Perhaps the signal is on its way right now, traveling through the void, destined to reach us in 100 years, or 1,000, or tomorrow morning. Or perhaps the silence is the message itself, a reminder that for now, we have only each other. Rest now in the quiet of the search. The telescopes are still pointed at the sky. The computers are still humming in the dark, and the static of the stars is still being decoded. The universe is big enough to hold its secrets for a long time, and we are patient enough to wait for the answers. You are a part of a world that is still listening, still dreaming, and still reaching out into the great, silent dark. As we move beyond the hopeful quiet of our radio telescopes, we must face the heavy, grounded reality of the physical world. We have spoken of signals, messages of light that travel at the speed of light. But what of ourselves? What of the dream that has lived in human hearts since we first looked at the stars and imagined walking among them? This is the story of the energy barrier, the invisible tax that the universe levies on anything with mass that dares to dream of crossing the interstellar ocean. Interstellar travel is not just a challenge of distance. It is a challenge of energy on a scale that dwarfs all of human history. To move a physical object, a ship, a crew, a supply of air and water, across the void requires a force so immense that it pushes the very boundaries of what a civilization can provide. To understand why we have not seen alien ships in our skies, and why our own reach remains so limited, we must look at the cold, uncompromising math of acceleration. In our current age, we feel proud of our achievements in space. We have sent men to the moon and probes to the edges of our solar system. But these journeys, though grand to us, are mere hops across a pond. To travel between stars, we must go much, much faster. The energy required to accelerate a spacecraft does not increase at a steady, manageable rate. It increases exponentially as you try to approach the speed of light. Consider a modest spacecraft, weighing perhaps 1,000 kilograms, about the size of a small car. To accelerate that single ton of metal to just 10% of the speed of light would require an amount of energy roughly equivalent to the total annual energy consumption of the entire human civilization. Think of every light bulb, every factory, every car, and every heater on Earth running for a full year. All of that power focused into pushing a single, small car to a fraction of light speed. And that is only the beginning. To reach 50% of the speed of light, the energy requirements grow into the realm of the impossible. To approach light speed itself would require infinite energy, which is why the laws of physics dictate that nothing with mass can ever reach that ultimate threshold. This is not a limitation of our engines or our fuel. It is a fundamental rule of the universe. Even if a civilization possessed energy resources far beyond our own, perhaps harnessing the power of entire stars, the physics remains the same. They might achieve 10% or 20% of light speed, perhaps even 50%, with truly godlike technology, but they can never break the wall. This means that a journey to a star system on the other side of the galaxy, even at half the speed of light, would still take 200,000 years. This energy barrier creates a profound isolation. It means that interstellar travel is not a casual endeavor. It is not a mission that any biological creature could survive in a single lifetime. It is not a project that any society, as we understand them, could sustain across the millennia. The crew that departs would be dead for thousands of generations before their descendants ever saw the light of a new sun. We often dream of generation ships, great wandering worlds where people are born, live, and die in the dark, their only purpose to maintain the systems for a future they will never see. It is a beautiful and tragic concept, but it raises questions that are more than just technical. What social structure could hold its purpose for 6,000 years? What language would they speak? What would motivate the 1,000th generation to keep the engines running for the benefit of descendants they will never meet? These are challenges to the very idea of human purpose over time scales that dwarf all of our recorded history. And then there is the problem of the ships themselves. What technology could function for hundreds of thousands of years without a single catastrophic failure? On Earth, we struggle to build machines that last for a century. In the harsh environment of interstellar space, bombarded by cosmic rays and tiny grains of dust that strike with the force of nuclear bombs at high speeds, the ship itself becomes a fragile sanctuary. Some look to the mathematics of general relativity for an escape, to wormholes or warp drives that might fold space and bypass the energy tax. But these are mathematical curiosities, not blueprints for the future. A wormhole would require exotic matter with negative energy, something that may only exist in the smallest quantum fluctuations. A warp drive would require energy quantities that exceed the mass of entire stars just to move a single ship. As you rest in the quiet of your room, let the weight of these numbers bring you a sense of grounded peace. The energy barrier is the universe's way of ensuring that every world is a protected island. It ensures that life, if it exists elsewhere, must solve its own problems on its own world. It protects us from the interference of others, and it keeps the stories of the stars separate and pure. The staggering cost of crossing the void is the ultimate guardian of the great silence. It is why the galaxy is not buzzing with ships and travelers. The universe is designed to keep everything apart, not out of malice, but through the simple, unyielding laws of mass and motion. Every star is an island, and every island is surrounded by an ocean too wide and too deep for any traveler to cross without paying a price that exceeds the wealth of worlds. We are part of a cosmos that demands a deep, ancient form of patience. We can look and we can listen, but we cannot yet touch. And there is a certain dignity in that. It means that our world, our Earth, is all the more precious because it is the only one we will ever truly know. We are the inhabitants of a rare sanctuary, held safe by the very energy that keeps the stars out of our reach. The stars are there, burning with a fire we can never join, and the void is there, cold and vast. But here, the air is warm, the ground is solid, and the night is quiet. You are safe in the center of the only world that belongs to you. The energy of the universe is vast, but it is the energy of your own life, your own breath, and your own dreams that matters most tonight. As we leave behind the physical walls of mass and energy, we must now step into a gulf that is perhaps even more unbridgeable, the distance between moments. We have looked at the vastness of the space between stars, but now we must look at the clock of the cosmos. The universe is approximately 13.8 billion years old. It is an age so immense that the human mind cannot truly grasp it. We can only use metaphors to try and touch the hem of its garment. This is the temporal paradox, the realization that even if the galaxy is full of life, we may simply be missing our neighbors because we were born at the wrong time. To understand why the universe feels so empty, let your mind drift into a grand visualization. Imagine that we could compress the entire 13.8 billion year history of the universe into a single calendar year. In this cosmic year, the Big Bang occurs at the very first stroke of midnight on January 1st. For months, the universe is a place of violent formation, stars igniting, galaxies colliding, and the heavy elements of life being forged in the hearts of dying suns. On this calendar, our own Earth does not even begin to form until September 2nd. Life, in its simplest, microscopic form, does not appear until September 21st. For most of the autumn and early winter, the world is a quiet place of single-celled organisms. The dinosaurs, those great rulers of our world, do not arrive until Christmas Day, and they vanish by December 30th. Now, consider our own place in this year. Modern humans do not emerge until 11:52 p.m. on the very last day of the year, December 31st. All of recorded human history, every empire that rose and fell, every war fought, every song written, and every discovery made, fits into the final 14 seconds before the stroke of midnight. And our technological civilization, the brief window in which we have been able to broadcast radio signals into the dark, occupies only the last tenth of a second of that entire year. 1/10 of a second out of an entire year. This is our window of detectability. For anyone to hear us, they would need to be listening during that exact cosmic instant, their instruments pointed precisely at our unremarkable sun. This creates the heart of our paradox. Even if intelligent civilizations are relatively common, arising perhaps once for every million stars, they still need to exist simultaneously. They must maintain their technological state during the same overlapping window of time. Imagine another civilization somewhere in the spinning arms of the Milky Way. Perhaps they arose on a planet orbiting a star that formed 8 billion years ago, long before our own sun was even a cloud of dust. They might have built sprawling cities, mastered the laws of physics, and sent their own signals into the void for millions of years, hoping for an answer. But they listened for an eternity and heard only the hiss of background radiation. Eventually, their star grew old, or their resources failed, or they simply moved beyond the need for communication. By the time humanity developed our first radio transmitters, that civilization might have been dead for 3 billion years. Their signals would have washed over the Earth long before we were here to receive them, passing through a world inhabited only by bacteria that could never know they were being spoken to. Or think of the opposite scenario. A civilization might be beginning its journey right now on a planet 50,000 light-years away. But their signals will not reach us for 50,000 years, and our signals will not reach them for another 50,000. By the time a single exchange could occur, 100,000 years will have passed. Will humanity still exist in 100,000 years? Will we still use the same technology, or will we have vanished like the civilizations that may have come before us? It is entirely possible that the galaxy is filled with the ruins of extinct worlds. Their signals have faded into noise, their great monuments have crumbled to dust, and their planets have returned to silence. We may be surrounded by the graves of millions of species that rose and fell while our ancestors were still single-celled organisms floating in primordial oceans. Many solutions have been proposed for the Fermi paradox, but temporal isolation is among the most compelling. Civilizations might be common across the vastness of cosmic time, but vanishingly rare at any single given moment. We are like fireflies flickering in a vast, dark forest. We glow for a brief instant and then go dark. The chances of two fireflies glowing at the same time, close enough to see each other's light, are extraordinarily small. Even our own sun has a finite lifespan. In about 5 billion years, it will begin to die, expanding into a red giant that will render our home uninhabitable. Any civilization tied to a single star has a window that is measured in billions of years at most. And Earth's window of habitability, the time we have left before the sun becomes too hot, is perhaps only 1 to 2 billion years. In the grand timeline of the universe, which will continue for trillions of years, a billion years is just a small fraction. We also search for radio waves because that is the technology we understand. But radio technology might be a brief phase in any civilization's development. We have had it for a century, and we are already transitioning away from broadcast radio toward directed signals that don't leak into space. A civilization 1,000 years ahead of us might use communication methods that are completely invisible to our instruments, such as lasers, gravitational waves, or quantum entanglement. They might have gone silent, not because they went extinct, but because they found better ways to communicate. The pioneer of SETI, Frank Drake, developed an equation to estimate the number of detectable civilizations in the galaxy. The most uncertain term, and perhaps the most important, is L, the length of time a civilization remains detectable. If L is millions of years, the galaxy should be buzzing with signals. If L is only a few centuries, most civilizations have already gone silent by the time their signals reach anyone else. Our own, L, is currently around 100 years. Whether it will extend to thousands of years or end tomorrow is unknowable. But there is a different way to look at this. Some researchers suggest that we might actually be among the first technological civilizations in the galaxy. The early universe needed time to produce the heavy elements necessary for rocky planets and complex chemistry. The first generation of stars contained only hydrogen and helium. These stars had to live and die, exploding as supernovae to seed space with the carbon, oxygen, and iron that life requires. This process took billions of years. Perhaps the 13.8 billion years that have passed were simply the minimum time required for a technological civilization to emerge. If this is true, we are not late to a party that has already ended. We are the pioneers. We are the first ones to achieve technology in a young universe that hasn't yet filled with intelligent life. This thought is lonely, but it is also full of a strange, quiet dignity. Instead of being separated from the past, we are separated from the future. The civilizations we wish to speak with do not exist yet. They are still billions of years away from evolving. By the time they look at the stars, humanity might be long extinct, our existence forgotten. Time creates isolation just as surely as distance does. Two civilizations could be perfect neighbors in spatial terms, orbiting stars just a few light years apart. But if one flourished and died 500 million years ago, and the other won't arise for another 500 million years, they might as well be on opposite sides of the universe. They can never meet, never communicate, and never even know the other existed. As you drift closer to sleep, let the ticking of the cosmic clock soothe you. We are not alone in the universe. We are alone in time. And time, like distance, is a barrier that no technology can overcome. We are witnesses to a tiny slice of the timeline, sending messages that won't arrive for centuries, hoping someone will be there to receive them, knowing that we won't be around to hear any reply. This is not conversation, but notes in bottles thrown into an ocean so vast that no bottle has ever washed ashore. But there is beauty in being the first. We are the part of the universe that is waking up. We are the ones who are counting the seconds and naming the eras. In this moment, you are here. You are a witness to the final seconds of the cosmic year. And as the silence of the cosmos presses in from all directions, remember that your life is a brief, brilliant flame in a long and ancient night. As we move away from the ticking of the cosmic clock and the distances between the stars, we must confront a hurdle that is perhaps even more fundamental. We've imagined that if we could only cross the ocean of space, or if we could only time our lives to match our neighbors, that the rest would be simple. We imagine a meeting of minds, a shared understanding, a handshake across the stars. But this assumes that an alien mind would work like ours. This is the problem of the mind, and it suggests that even if we were to find our neighbors, the conceptual gulf between us might be so vast that meaningful communication remains forever impossible. When we imagine aliens, we tend to imagine beings that are somewhat like ourselves. Our science fiction has trained us to expect humanoids, beings with different skin or a few extra limbs, but who nonetheless speak in symbolic languages, value logic, and perceive the universe through senses we can recognize. But this is almost certainly a failure of imagination. It is a human-centric view of a universe that has no obligation to follow our biological blueprints. To understand how truly alien another intelligence might be, we don't need to look at the stars. We only need to look at our own world. Consider the octopus, a creature that has shared this planet with us for hundreds of millions of years. An octopus has 9 brains, 1 central brain and 8 semi-independent brains distributed through its arms. Each arm can taste, touch, and make decisions without ever consulting the center. Though we share a significant portion of our genetic code with them, we cannot truly communicate with an octopus. We have lived alongside them for eons, yet their experience of the world remains fundamentally closed to us. Or consider the dolphins. They possess a language of sorts, using signature whistles that function as names. They understand grammar and can recognize themselves in mirrors. They are intelligent by any definition we have, yet after decades of study, we cannot have a conversation with a dolphin. We don't know if they contemplate their own mortality or if they wonder about the stars. If we cannot bridge the gap with an intelligent species on our own planet, breathing our same air and swimming in our same oceans, how can we expect to understand a mind that evolved under a different sun? An alien species would have no shared evolutionary history with us. They might not use DNA or proteins or anything we would recognize as biochemistry. Their intelligence might work on principles entirely foreign to our understanding of a mind. What does an intelligent being look like if it evolved in the freezing methane oceans of a distant moon? What if it is a collective organism, a hive mind where individual consciousness does not exist? What if it experiences time so slowly that our entire civilization passes in what seems to them like a single afternoon? Image comparing the biological building blocks of Earth life, like DNA and proteins, with theoretical alien biochemistry, like silicon-based structures. We assume that an alien civilization would use radio waves because we have discovered them and found them useful. But this assumes that they develop technology along the same pathways we do. It assumes they have sensory systems that make radio waves obvious and useful. Most importantly, it assumes they want to communicate. We are social creatures. Our survival as primates depended on our ability to coordinate and share information. But an intelligent species that evolved as solitary predators might have no concept of communication at all. They might be brilliant problem solvers and masters of physics, yet be completely uninterested in exchanging thoughts with others. Even those who do communicate might do so in ways that leave us blind and deaf. Human language is built on discrete symbols arranged by grammatical rules, a product of our specific brain architecture. Other forms of intelligence might communicate through continuous signals, or through direct neural interfaces that bypass symbols entirely. They might communicate by manipulating their shared environment, or through distributed computations that don't map onto anything we would call language. When we sent the golden records on the Voyager spacecraft, we filled them with greetings in 55 languages and the sounds of our world. It was a beautiful human gesture, but an alien finding that record might not recognize it as a message at all. Our images rely on visual conventions that are culturally specific to us. Our music assumes a neurological response to sound that may be unique to human biology. To an alien, the golden record might be nothing more than a piece of space debris, a strange artifact to be catalogued and forgotten. The same problem applies to the signals we hope to receive. We search for patterns in radio waves that show mathematical structure, assuming that math is a universal language. We believe that any civilization capable of building a radio must understand the properties of prime numbers or the ratios of a circle. But even mathematics is a human construction. Our symbols, our proofs, and the concepts we value reflect our own cognitive biases. An alien mind might have developed completely different mathematical structures, ones that solve the same physical problems but look nothing like our own. We might be bathed in alien communications right now, signals washing over the Earth constantly, yet be unable to recognize them because they don't register as signals to our eyes and ears. We tend to define intelligence in terms of what humans are good at: abstract reasoning, tool use, and language. But this is a circular definition. We are measuring other minds against ourselves and declaring our own traits to be the standard. A species with a different history might have extraordinary spatial reasoning, but no concept of time, or a perfect memory, but no capacity for abstract thought. They might be intelligent in ways we are simply not equipped to perceive. This conceptual gulf is the third great barrier to meeting aliens. Two intelligent species could inhabit neighboring star systems, broadcast signals at each other for thousands of years, and never achieve a single moment of understanding because their minds are too different to bridge the gap. They might each conclude they are alone, seeing the other's signals as nothing more than the meaningless noise of the stars. As you drift in the quiet of this thought, let the mystery of the mind bring you a sense of wonder. We are not just searching for someone to talk to. We are searching for a way to understand existence itself. The silence we hear might not be an absence of life, but an absence of common ground. The universe could be teeming with awareness, vibrant and full of thought, yet remain silent to us because we have not yet learned how to listen beyond our own biology. It is a humbling realization. It reminds us that our way of seeing the world, our languages, our math, our stories, is just one way among an infinite number of possibilities. We are a single note in a grand, complex symphony that we are only beginning to hear. And while the conceptual gulf is wide, it also makes our own consciousness more precious. We are the ones who speak this specific language. We are the ones who see the universe through these specific eyes. The silence of the stars is a reminder to value the minds we can understand. It reminds us to cherish the conversations we can have here, on our own world, with our own kind. For now, we are the only ones we know who can share a dream, or tell a story, or wonder about the dark. The minds of the stars may be forever alien, but our own minds are a light we can share. Rest now in the stillness. The universe is full of mysteries that may never be solved, and minds that may never be met. But you are here, part of the great experiment of awareness, and in this quiet moment, that is enough. The night is silent, the stars are far away, and the dream of understanding continues, slowly and peacefully, in the deep of the night. As we drift closer to the final thresholds of this cosmic journey, we must turn our minds toward a possibility that is perhaps the most unsettling of all. We have looked at the barriers of distance, the walls of time, and the gaps between different ways of thinking. But there is another explanation for the great silence, one that suggests the universe appears empty, not because it is too large, but because the path from life to the stars is blocked by a nearly insurmountable obstacle. This is the concept of the Great Filter. Imagine the history of a world as a long, perilous staircase. The first step is the transition from dead chemistry to the first spark of life. The next steps involve the evolution of complex cells, then multicellular organisms, and then the emergence of intelligence and the invention of technology. At the very top of the staircase lies the ability to leave the homeworld and spread across the galaxy. The Great Filter theory suggests that at some point along this climb, there is a step so difficult or so dangerous that almost no one ever makes it to the next level. The chilling question for us, as we rest here on our own planet, is where that filter lies. If the filter is behind us, we are extraordinarily lucky. It might be that the jump from simple bacteria to complex life is the bottleneck. On Earth, life remained single-celled for nearly 3 billion years. It took a strange, perhaps 1 in a trillion accident, the merger of 2 different types of cells, to create the complexity needed to eventually build bodies and brains. If that merger almost never happens on other worlds, then the galaxy may be filled with planets covered in nothing but silent, microscopic slime, forever unable to contemplate the stars. Or perhaps intelligence itself is the filter. Life has flourished on Earth for 4 billion years, yet human-level intelligence evolved exactly once. Dinosaurs dominated the planet for 165 million years and never developed the need for technology or the curiosity to look beyond their own horizon. If the path to a thinking mind is a bizarre anomaly rather than a natural outcome of evolution, we may be alone simply because the dice of life almost never land on the side of intelligence. But there is a darker side to this theory. If the filter is not behind us, it means it is waiting in our future. It suggests that perhaps many civilizations reach our stage of development, but then they hit a wall that they cannot survive. We are a species that has possessed the power to destroy ourselves for less than a century. Between nuclear weapons, engineered pathogens, and the destabilization of our own climate, we have already faced several moments where our history could have ended in an afternoon. The same intelligence that allows a species to build a radio transmitter also allows them to build weapons of unprecedented destruction. Perhaps every technological civilization follows a similar trajectory, reaching a point where their power exceeds their wisdom, and they annihilate themselves before they ever learn to travel the stars. This would explain why the galaxy is quiet. It would be a vast, dark graveyard of brief, flickering flames that went out as quickly as they were lit. And then there are the theories of those who survive by staying silent. This is the dark forest hypothesis. It imagines the universe as a forest filled with hunters, where any civilization that reveals its location risks being destroyed by another that sees it as a potential rival for finite resources. In this world, the safest strategy is silence and hiding. If this is true, our attempts to shout into the dark are not just futile, but dangerous, an invitation for a threat we cannot yet conceive. As you settle into the deepest part of your rest, let these thoughts be a reminder of the profound responsibility we carry. If we're the only ones to have passed the filter, or if we are the only ones currently attempting the climb, then we are the guardians of a miracle. We are the survivors of a cosmic lottery, the ones who are still holding the torch in a cavern that might otherwise be empty. The great silence is not a verdict of doom, but a call to cherish the life we have here. It reminds us that our survival is not guaranteed by the universe, but is something we must earn every single day. We are part of a rare and beautiful experiment, a species that has been given the chance to look back at the stars that forged us and ask what it all means. The night is vast, and the filters of the cosmos are many. But we are still here. We are still thinking, and we are still dreaming. You are part of a world that is still trying to be the exception to the rule. Rest now in the knowledge that your own awareness is a light that has defied the odds, a flame that is burning brightly in the heart of the great, silent dark. We have traveled through the impossibly wide oceans of space, through the deep, silent corridors of time, and through the mysterious labyrinths of the mind. We have confronted the cold walls of physics and the chilling possibility of the filters that may extinguish life before it ever learns to fly. And now, we reach the final shore of our journey. As the stars continue their slow, ancient dance above us, we must ask ourselves what it all means. If the universe is truly as empty as it appears, if we are indeed the only ones, what does that change about our place in the story of the cosmos? This is the final movement, the precious flame. For the vast majority of our history, we humans believed we were the center of everything. We believed the Earth was the immovable anchor of the universe, and that the sun, moon, and stars were mere lanterns hung in the sky for our benefit. We saw ourselves as the pinnacle of creation, the very point of the entire cosmic drama. But as our science matured, it stripped away these comforts one by one. Copernicus showed us that we orbit the sun. Hubble showed us that our galaxy is just one of billions. And today, our telescopes show us a universe so vast that our entire planet is less than a speck of dust in a hurricane. This journey has been a long lesson in humility. Each discovery has pushed us further from the center and made us feel smaller and more insignificant. The search for alien life is, in many ways, the final stage of this process. If we were to find that the galaxy is teeming with life, that intelligence arises on every second world, we would know for certain that we are not special. We would be just one more example of what happens when chemistry becomes complex enough to wonder about itself. There would be comfort in that. We would be part of a great universal family, even if we could never reach out to touch them. But what if the opposite is true? What if the silence we hear is not just a temporary delay, but the permanent truth of our existence? What if, in all those hundreds of billions of galaxies, we're the only minds that have ever woken up? If this is true, then our insignificance is suddenly transformed into a staggering, almost terrifying significance. If we are the only minds in a universe of 200 billion trillion stars, then we are not ordinary. We are a miracle. We are the only part of the universe that has finally opened its eyes. Think of the universe as it was for the first 13 billion years. It was a place of extraordinary precision and mathematical beauty, governed by laws of physics that operated flawlessly in the dark. Stars formed, burned, and exploded in magnificent spectacles that no eye ever witnessed. Galaxies collided and merged in silence. The fundamental laws of the cosmos were a performance without an audience, a question with no one to ask it, and a story with no one to read it. Then, on this one unremarkable planet, chemistry became biology, complexity became awareness, and for the first time, the universe had a witness. We are the patterns of matter that have finally learned the rules that govern matter. We are the universe becoming aware of itself. We are the cosmos looking back at its own history and discovering that it exists. If we are alone, then the fate of intelligence in this corner of the universe rests entirely on our shoulders. There is no one else to carry the torch if we allow it to go out. No other civilization will build the telescopes to see the beauty of the nebulae. No other mind will ask why the laws of physics are the way they are. If we were to vanish, the galaxy would return to a cold, unobserved emptiness. The great experiment of consciousness would end, and there might never be anyone else to try again. This is the true weight of the Fermi paradox. It is not just a puzzle for scientists, it is an existential responsibility. The loneliness we feel when we look at the stars is not a reason for despair, but a reason for a profound, quiet pride. We are the precious flame in a long and ancient night. We search the sky not because we expect to find a reply, but because searching is what minds do. We ask questions because questioning is how we understand our place in the story. As you rest now, let the silence of the room and the silence of the stars wrap around you like a warm, protective cloak. The impossibility of meeting aliens is not a tragedy. It is a description of the universe as it appears to be. A cosmos of isolated islands, each holding its own unique light. Whether we are one island among many or the only one in the sea, our duty remains the same: to make our brief flame of awareness burn as brightly as possible. We owe it to the stars that forged us to be the best witnesses we can be. We owe it to the 13 billion years of silence that preceded us to make our voice count. We are the part of the universe that knows, and knowing is a gift that is better than any alternative. For now, there is a voice in the cosmos, ours, and it is a voice that speaks of wonder, of curiosity, and of love. The universe does not owe us companions, and it does not owe us answers. We are accidents of chemistry and time, patterns that emerge from chaos for a brief moment before returning to it. But while we are here, we are something the universe has never been before. We are the part that wonders. We are the part that dreams. The night is vast, and the stars are far away. But you are here, you are safe, and you are part of the miracle. Let the ancient light of the galaxy find you as you drift into a deep, peaceful sleep. The watch continues, the search goes on, and the flame continues to burn, bright and steady, in the heart of the great, silent dark. Everything is as it should be. The silence is not empty. It is full of the potential of what we might yet become. Sleep now, for the universe is wide, and its only witness is finally resting.